Every man-made article or structure uses materials extracted from the earth, from the forest, the quarry, or the mine. For centuries, the knowledge of how materials could be shaped or how they behaved under load lay in the hand and eye of such craftsmen as carpenters, stonemasons, blacksmiths, and iron founders. But in the 19th century, everything changed. The railways arrived and steam locomotives replaced horses. Iron bridges and roofs were required of unprecedented scale. Iron was used in shipbuilding, and metal chains replaced ropes. The age of iron and steam had begun. This new age produced its own problems, and it soon became urgent to have more accurate knowledge of the new engineering materials. Designers had to combine safety with economy, and this was to be achieved by improved testing techniques. One man, David Kirkaldy, made a unique contribution in developing a systematic approach to the subject. He was a Scot, born in Dundee, and first worked as chief draftsman for a Clyde shipbuilder, and several of his exquisite original drawings survive. In 1861, he left shipbuilding to become an independent tester of constructional materials, and began by designing his own testing machine. His drawings were done at home, and the huge machine was built in Leeds, entirely at his own expense. In January 1866, the machine started work in London at the Grove in Southwark. As business grew, David Kirkaldy had the present purpose-built building designed to house the machine, and the testing works in Southwark Street was opened on the 1st of January 1874. The machine is 47 feet 6 inches long, and its operation is basically simple. Water at high pressure is pumped into the cylinder, and the ram forces the crosshead and the movable carriage to the right. Specimens to be tested in tension are fixed to the left of the carriage, and those to be tested in compression to the right. The load on the specimen is transferred by the horizontal lever to the steel yard, where the load is measured. The machine was designed to apply a 440-ton load and to accommodate a specimen 21 feet long. A tensile test in progress shows the main features of the machine. Here, the steel bar to be tested is gripped by wedges, and the operator stands at the steel yard and controls the inlet of water into the cylinder and measures the load at the same time. David Kirkaldy kept meticulous records of test results in his office from clients all over the world. These records contain results of tests following major engineering accidents, notably the Tay Bridge disaster of 1879. The North British Railway Company opened their bridge over the River Tay in May 1878. In June the following year, having tested the bridge for the Royal Train, Queen Victoria crossed the bridge on her way from Balmoral to London. But just 6 months later, disaster struck the bridge.
On the stormy night of Sunday 28th December 1879, the 5:20 Edinburgh-Dundee train reached the south end of Tay Bridge just after 7 o'clock when the storm was at its worst. On reaching the central high girders, a gust of wind forced the train against the leeward girders. The train, 75 people, and the 13 girders all fell 90 feet into the river. There were no survivors. In March 1880, parts of the girders were salvaged from the bed of the river, brought to London and tested on Kirkaldy's machine.
3 generations of the Kirkaldy family ran the testing works until the grandson, also David, retired in 1965. The fate of the building and the testing machine was then in doubt. Eventually the building was refurbished and the upper 3 floors were let. A museum trust was formed to maintain the machine in working order, and thus the Kirkaldy Testing Museum was formed. A group of friends of the museum carry out valuable restoration and conservation work and run the machine on open days. The techniques of materials testing were to develop away from large all-purpose machines towards small, dedicated apparatus to carry out special tests, like this cement briquette tester. Concrete cubes were also regularly tested on a quality control basis. The museum is dedicated to telling the story of product quality control and the important contribution of the Kirkaldy family in the history of safety in engineering design. David Kirkaldy's philosophy and approach to materials testing is encapsulated in the firm's motto.